Hi students, in our previous classes we have discussed about interference, diffraction. From today onwards I have to learn about polarization. Let us see what is a polarization. Interference and diffraction phenomena showed that light has a wave nature. We already know the waves has both particle nature and wave nature. That means the light here having the wave nature we have studied in our interference and diffraction phenomena. And now this phenomena is used to find wavelength of light, and they do not give any indication regarding to the character of waves. So Maxwell developed electromagnetic theory and suggested that light waves are electromagnetic waves. Now that means the waves consisting both electric field and magnetic field. In our previous classes we already discussed about transverse waves and longitudinal waves. See how the transverse wave will propagate and how the longitudinal wave will be propagate. And see what is the electromagnetic wave, how the electric field and magnetic field are propagating. That means both are perpendicular to each other. So electromagnetic waves are transverse waves. So it is obvious that light waves are also transverse waves. We are considering the light waves as EM waves. So whenever the EM waves are transverse waves, then automatically the light waves are transverse waves. Now the longitudinal waves are waves in which particles of medium oscillate along the direction of propagation of wave. That means particles within the longitudinal wave that oscillates along the direction of propagation of waves. That is an example sound wave. Sound wave is the best example for the longitudinal wave. And transverse waves are in which particles of medium oscillate perpendicular to the direction of propagation of wave, like electromagnetic wave. In the electromagnetic wave, in the previous slide we already seen that the both electric field and magnetic field are perpendicular to each other. That is an electromagnetic wave. That means that is a transfer wave. So sound wave is the best example for longitudinal wave, and electromagnetic wave is an example for transverse waves. Now the polarization concept that is possible in transverse waves. So according to Maxwell's electromagnetic theory, light waves are transverse waves. So this theory says that light is an electromagnetic disturbance in which the electric and magnetic fields are mutually perpendicular and lie in a plane and propagates in a direction perpendicular to this plane. So both electric fields and magnetic fields are propagating mutually perpendicular, and there is also a perpendicular direction to the plane. Out of these two fields, eyesight is produced by electric field vector E. So we can say that light waves are electric waves. So by our vision, we can easily say that those are electric waves. As far as light is concerned, vibrations in light refer to vibrations in E. Now the vibrations of light wave are always perpendicular to the propagation of direction. So in a source of light, different atoms in the source emit different wavelengths. So let us consider a source that may be a monochromatic source or a polychromatic source. The atoms, that means the light, different atoms in the source emit different wavelengths. So the vibrations are confined to one plane in every wave train. So there will be a single plane to each wave train. But the vibrations of one wave train and next wave train need not be in a plane. So whenever we are considering a single wave train, that is in plane. So when comparing to two wave trains, there is no need to be in a single plane. Both the wave trains that doesn't lie in the same plane. So in any ordinary light emitted by a source, the vibrations are in all possible directions with equal probabilities. That means the light dispersion it may be equal in all directions in a plane perpendicular to the direction of wave propagation. So see, let us know what is a polarized light and what is an unpolarized light. So whenever we are taking an unpolarized light, how it will be a polarized light. Polarized light means vibrations lie on a single plane only. See, that means the plane of vibration lie in a single plane. Unpolarized light. Unpolarized light means superposition of many beams in the same direction of propagation but each with a random polarization. Superposition of many beams in the same direction of propagation but each with a random polarization. You have to understand the plane of vibrations, that means the vibrations lie in a single plane in polarized light. Whenever we are taking the unpolarized light, superposition of many beams in the same direction of propagation but each with a random polarization. See, polarization of wave, how it will propagate. Means unpolarized light, that is a light which the planes of vibrations are symmetrically distributed about the propagation of direction of wave. Whenever we are considering the plane polarized light, it is a wave in which the electric vector is everywhere confined to a single plane. Electric vector is everywhere confined to a single plane. So a linearly polarized light wave is a wave in which the electric vector oscillates in a given constant variation. So here there is a concept of electric vector which is confined to a single plane in plane polarized light and gives constant orientation. That means the orientation is a constant within a given space. So types of polarized light: unpolarized light, linearly polarized light, partially polarized light. Let us see. It consists of sequence of wave trains all oriented at random. It is considered as the resultant of two optical vectors components which are incoherent. That means whenever we are considering two wave trains, they are oriented at random. The orientation is random direction. So it is considered as the resultant of two optical vectors components. Resultant of two vector components, it is incoherent. We already know about coherence. So here those are incoherent. Now linearly polarized light. It can be regarded as a resultant of two coherent linearly polarized waves. So it is a resultant of two coherent lights, two coherent sources, polarization. And partially polarized light, it is a mixture of linearly polarized light and unpolarized light. It's a mixture of polarized light, and that means linearly polarized light and unpolarized light, then it is said to be a partially polarized light. Now let us see how many types of polarization we have to study it in our subject today. So there is a three types of polarization: linear polarization, circular polarization, elliptical polarization. You have to understand there is a difference between the circular polarization and elliptical polarization. Both are not same. Okay, now let us see what is a linear polarization or plane polarization. See how the unpolarized light will be changed into plane polarized light whenever we are using a polarized. Plane polarized wave, electric field vector oscillates along a straight line in a one plane. See how the non-polarized light, whenever it passes through a polarized, how it will convert like a polarized wave. Okay, and last one is a analyzer. So circular polarization that consists of two perpendicular plane electromagnetic waves with equal amplitude and 90 degrees phase difference. Two perpendicular plane electromagnetic waves. Let us consider two waves, two EM waves with equal amplitude and 90 degrees phase difference. So plane of oscillation rotates around the propagation axis that may be right circularly polarized. That means clockwise polarization, or left circularly polarized. That means counterclockwise. That means anti-clockwise. Okay. If we look from the source and rotation of E vector, see how the E will propagate is clockwise, then it is right elliptically polarized wave. Okay, clockwise, anti-clockwise. Okay, if we took from the source and rotation of E vector is clockwise, then it is a elliptically, right elliptically polarized wave. If it is anti-clockwise, then it is left elliptically polarized wave. And means it is a resultant of two coherent waves having same amplitudes and a constant phase difference of 90 degrees. In this type of light, the magnitude of E vector remains constant. So magnitude of E is constant. If the light is coming towards us, we would observe that tip of the E vector transit a circle. So see here, finally we are getting a circular polarized light. Okay, if we look from the source and rotation E vector is clockwise, then it is said to be right, and it is anti-clockwise, then it is said to be a left circularly polarized wave. Have you seen? Next, consists of, that means elliptical polarization, consists of two perpendicular waves of unequal amplitude that differ in phase difference by 90 degrees. So the tip of the resultant electric field vector describes an ellipse that because of the unequal amplitudes or maybe a phase difference of 90 degrees, there may be occur in elliptical path in any fixed plane intersecting and normal to the direction of propagation. So circular and linear polarization, special cases of elliptical polarization. This is a special case. That means, let us see how the elliptical polarized light will be. It is the resultant of two coherent waves having a different amplitudes, unequal amplitudes, and a constant phase difference of 90 degrees. In elliptically polarized light, the magnitude of electric vector E rotates about the direction of propagation. If light is coming towards us, we would observe the tip of the E vector traces an ellipse. So the side view of E vector gives flattered helix in space. Have you seen that? Do you know the difference between circular and, that means circle and ellipse? So here we are getting an elliptical part. Okay. So left-handed circularly polarized light. So the concept of quarter wave plate and half wave plates, we will study it later, and how it will be a linearly polarized light.